Welcome everybody to the 7th FAIRmat Users Meeting. I'm really excited about the program today. So typically what we try to organize in here is a range of invited talks from really senior PIs, also with data stewards and with more junior people. And I think this is a really good combination for what we're doing here. So we'll just go ahead. A couple of things that I said that I will going to bring some updates or some use cases of what people try to do with NOMAD, but I think there are some mandatory introductions that I need to do just in case you are new in the community and you don't know what FAIRmat is. So we are a consortium that is funded by the National Research Data Infrastructure Program of Germany. And basically our mission is to build a federated data infrastructure for solid state physics and for these aspects of material science. And the values are very clear, so we do everything with fair data in our target. Everything that we do is open source. We promote open science, and we do with you in a very bottom-up approach. And this is why this user meeting is very, very important. So this is a picture from 1 year ago from the every users meeting we coupled with a project meeting, and this was last year around this time. I guess the weather was a little bit better then. And basically we work mostly in this building in here. So we are a project that we don't scatter the people around. We just try to be concentrated in a big group to try to build something a little bit consistent and bigger, that can scale better. So what do we do? So we do many things. We try to do standardization, data models, RDM education for the people and so on. But the main thing that we do is NOMAD. And this is an RDM ecosystem, which I will try to introduce you some features about this. Many of you know already. Many of you are maybe super experts already developing. So for some of you, this might be completely new. But for this, I wanted to bring you a little bit of a history of how we developed. So NOMAD was a platform that was up and running in 2014 already, and it was an archive and repository for ab initio calculations. And then in 2021, FAIRmat starts at the very end, and then we take over what it was a database of computational data, and then we just really need to convert it in something bigger. So of course, the theory and computation is very prevalent in NOMAD, so we keep on increasing the support for parsers and codes. I think there are more than 70 to 80 codes. I lost the count right now because we are getting a lot of contributions from external people. We will hear about this later, but the database is really big. There are nearly 20 million entries published already, more than 19 million entries, more than 4 million materials represented in there, and then we increase the methods that we support. Now we also support Green's function methods for the theoreticians in there, the MFT, molecular dynamics. We are trying to bring a lot of features about how to support custom calculation workflows. And basically how it works for most of the cases from the standardized, you basically zip the files in the central NOMAD installation, and then NOMAD detects these files, and then you can share them straight away with the whole community. And then the data becomes fair, open, and AI ready. So about people developing new codes and parsers. So we of course do a lot of the work, but there's a lot of the community doing this, and we have two invited talks about this for the calculation. So here is Cecilia, and then Satya is from the physical science data infrastructure of the UK, and he uses NOMAD to develop his platforms in there. Unfortunately, I think he could not join in person today, so he will give his talk online. Yeah, Brexit. Yeah. So what we do in FAIRmat is not calculations anymore. So it's a much wider thing. So we need to develop an infrastructure. We need to develop an infrastructure that covers synthesis process, advanced characterization, full experimental pipelines, and then of course demonstrate this with use cases, which could be heterogeneous catalysis, could be solar cells, which is my field, could be batteries, or could be metal organic frameworks. So this brings me to 2022, where we start to put features in the platform that allow us to somehow start developing how this could look for all of these needs. So we start putting a lot of development in integrating with Nexus, which is a standardized data format originally developed for large-scale infrastructure, synchrotrons, and so on, but we in FAIRmat try to extend for many more techniques, and I guess we will hear about this in other talks later. we try to put ELN features, electronic laboratory notebooks, in there, and then we start like playing with something that is called North, that I will tell later what this is about. And then in 2023, we keep on pushing more software, and then start to appear as what we call NOMAD Oasis, which I will extend quite a lot in the presentation. The NOMAD Camels, and then we also publish the software like as a paper and a repository. So from this point, NOMAD comes in two main flavors. So one in the left hand side is the NOMAD with the indigo like dot in there. So this represents our central installation. It's the central repository where people just interact mainly on individual basis. They like deposit data in there. They also consume data, and they use like some analysis tool in there, and they explore everything. And then it comes the NOMAD Oasis version, which is something that you install in your lab, in your institution, or in your universities, and you completely customize to whatever you need. Then it comes NOMAD Camels, which is something that gets developed in a like branch of FAIRmat that heavily works in Erlangen. And this is about automating instruments and then like synchronize them together and looping so that you can really automate this. And if you want to hear more about this, I will not talk in this presentation, but Alex Fuchs is sitting in there, and he will be the whole day in there. He is the real person and expert to talk about this. So today we'll focus quite a lot in NOMAD Oasis, and all the use cases that I will bring is about this. So I brought here a set of features that you might know that you can use with NOMAD. But for example, the first thing is the ELN. This is some of the things that we started to bring. So basically, you can define some interfaces that allow you to annotate your entries and your samples in there. But the whole idea is that we keep on fostering like structured data with very well-controlled definitions. So when you have quantities or values in there, they come with unit control, with type control, and so on. And this is what it powers the whole infrastructure that you can search everything and so on. So the whole idea is that you don't annotate everything manually, but you can augment your data. So there you can like configure your NOMAD installation that it does automatic processing of this data. So let's say, for example, that you upload a spectrum, in this particular case is of a solar cell, and then you basically can automate NOMAD to array. I will read this spectrum, I will plot it, but then I will derive like quantities automatically from this that allows me to search this data at a scale and compare. So in this particular case, it derived a bandgap from this spectrum, it fitted a exponential decay in there, and derived like more quantities about this. Then we are bringing a lot of support for large files and for the Nexus format for HDF5 files. I think this is heavily important. In any modern material science lab, you produce multidimensional characterization measurements, a lot of like image files and so on. And then typically all the ELNs about in there was about like annotating like in a Word file, like tiny little things. So we want to bring this that you can use NOMAD with 80 gigabytes, microscopy files and so on. And then we bringing a lot of support for this. And then it comes North, that I briefly mentioned before. I think this is something that I find particularly cool. So North stands for NOMAD Remote Tools Hub. And this is basically on top of NOMAD and all the database that you have in there, we allow you to run analysis tools and so on. And then you can even customize these tools. The most popular one is, of course, Jupyter Hub. So you can run Jupyter notebooks with very well-defined environments in there. And the idea with this is not that it's a Google Colab. The idea is that your files live directly in there, and then you have user rights of your file. And then if you want to analyze, for example, like a 80 gigabytes microscope file, you don't need to download it locally, then like upload it in there, so you have it directly in there, and then you can run it. But North is not only about like notebooks and Jupyter Hub. You can do whatever you want. Like in there, you can also spin up desktop tools. For example, ImageJ or Fiji for image analysis, or Igor Pro, and I think Lawrence might show some examples of this later on. So you can build, because all the data gets indexed and structured, you can build what we call search apps. And this is like kind of this database in a database concept. So basically, you can bring dashboards in there that allow you to search all the data at a scale. I think this is one example about like searching some molecules. But in the community, we're seeing examples that they use these to track the inventory in their lab, to track their measurements, their experiments. And we internally even use it to track repositories. And recently, we've been building a hackathon to track cooking recipes. Yeah, of course, all the data can be shared selectively. So basically, when you have what we call uploads or projects, you can just decide, okay, I want to give access to this person with a reviewer mode, so I can see all the files but cannot edit. Or I can select like a group of people and add it like to the upload in there. I think the group feature is like something that is relatively new from the last thing. Yeah? I can show something about this. Okay, this brings me to a scalability problem. So yeah, we needed to put a lot of features. We need to cover like a broad community, and then this brings me to 2024, which is crazy that this was only last year. And then, so the first thing that we do is like we getting a lot of, we cannot support like so many people. So the first thing that we do is like we open a Discord server, and many of you are already in there. There are like more than 620 people already in there in 1 year. And this is our main like tool to streamline all the support that we can bring in there. And then the other thing that we did in the software is that to customize NOMAD, before you needed to edit the main like base source code in there. So the whole idea is now that you just write what we call plugins, which are basically repositories, and this allows you to customize your installations. So we have one of these search apps to track the plugins in there, and I just realized that there are like more than 160 public plugins already. So around 60 or something like this are developed by us, by the core team, but then like the other 100 are by the community, and I think this is already very impressive how this has a scale. The most popular plugins are schema packages, but already from these search apps, we have like already more than 100, and this shows like the whole variety that it is in there out in the community. So yeah, now I just wanted to show you some examples on how people use these platforms in different contexts. I wish I could show all of them, but I guess we will hear from the community later on. So the first people that use the platform is ourselves. In FAIRmat, we try to exploit this. So we develop, but we also try to demonstrate with this. So we do it by, many of the use cases is by creating databases and datasets. So we've done this for solar cells, from experimental data created from literature, and then we are like trying to update this database now with language models so that it gets like live in there. A couple of months ago, we released the heterogeneous catalysis database. This is an experimental dataset that Julia and Annette Tunschke put a lot of work on. It contains more than 2,500 entries of experimental heterogeneous catalysts of all this like wealth of chemistries with their activities, with all the type of reactions, the reactants and products that they use, and is highly searchable with all the experimental data in there. And then of course then it comes with this so that you can explore it interactively. Yeah, and then about catalysis, I guess we will hear later on from Marcel Rich and Carla about how they implementing a NOMAD basis for electrocatalysis at the HCB. I'm very excited about this. This is a new format that we put in where like the lead scientist of the lab comes with a data steward, and then everybody like tells a little bit the story on their side. So this is very popular in solar cell research. I think we have more than 8 labs across the world actually that use this for this, and several European projects. Basically they use this to track the full synthesis process in there. So from how they clean the substrates to every deposition process that it happens to the metrics, and then they even build like a lot of customized analysis apps that they run on top of NOMAD. So if you want to learn more about this, I think there are like a lot of HCB people in here that are the main developers in there. So this is not on us. So I think Edgar was around there. I don't know. Yeah, Matthias. Yeah. So talk to the people later if you're interested in this. Then it comes people using this for really advanced characterization techniques. And this is the group of Lawrence who will tell us a lot about this. So I will not spoil a lot, but it's about multidimensional photoemission spectroscopy. And he uses, he actually is a really good NOMAD basis developer. We learned quite a lot from him. So then we also have Matteo, which I think will talk about some data models and experimental part of this. This is from some kind of a partnership that we have with some institutes in Italy. And from the internal people, if you don't know who Matteo is, you might know him as Trog, yeah, in Discord. So it's like more than 100 messages from him. He joined last year, and with this, I think this is what it actually makes us improve the platforms quite a lot, like having this direct feedback and the documentation and so on. So I mean it like we're really thankful for this. So another of the use cases that I'm really excited about, of course, because it's part of my field and so on, is this at the DTU. at the Denmark Technische University in Copenhagen. So this group is led by Andrea Crovetto. He's a young PI who started to set up his lab while FAIRmat was like 1 year old or something like this. So he's got like a small group. This is Lena. She's a PhD student from Andrea, and she was presented last year in the users meeting in here, and then Eugene. So the group is basically 4 people during the last 2 years. And so they were setting up their physical lab in there, and then like we were helping them to build the digital part of it. So the lab is about materials discovery, experimental materials discovery, and it's high throughput experimentation. So basically they have sputtering chambers which deposit combinatorial samples in there. They run this in very controlled atmosphere because they grow phosphorsulfide samples, which are very difficult materials to grow, and they require some toxic gases and so on. And basically what they produce are substrates that have a compositional spread across there. And then they go through this substrate in here, and then they measure like different measurements in every point, so they like can create a lot of like high throughput data in there. So the full lab runs now in NOMAD, completely from the inventory to the data registry to the analysis. So they have like an inventory of their targets that they use in their sputtering machines in there. The targets get linked in the workflow and the synthesis processes. They track absolutely everything that comes from the sputtering machines and also from the annealing. What was the flow of the gases in there? What were the temperatures of the substrates? And then they go with the samples and they do high throughput characterization. So they map everything like X-ray diffraction data, compositional data, and all of this stuff. They're actually plots from NOMAD. So this is a compositional map that it gets built automatically, and then all the scans across one library from the X-ray diffraction patterns. So just last month, so we actually have like an overall look, and then we help them develop something that gives them like a whole breadth of how many samples they could grow. And like with 4 people, this lab, which is a new lab, in completely like new chemical spaces, they grew 11,000 experimental samples, which is represented in this plotting here. I don't know, perhaps if you're a computationalist, like 8,000 samples doesn't tell you a lot. But as an experimentalist, this is very, very impressive to do, and it's really crazy that they can track this at this scale right now. And this brings me to the point that how do people analyze this? No? How do you handle this? And this brings me to 2025, which is this year, what we've been like trying to push in the last months. One of the things is what we call now NOMAD actions, and this comes from in the last version of NOMAD, in the 1.4, there was like a massive something changed in the backend that it was like a really big change, but people in the front end really do not know that, but it was like so we changed something in the processing, and this allows us like to do much more in the future. So what are NOMAD actions for the people that? So these are basically executable workflows in NOMAD, but they can like run like much longer tasks and so on. So they are like an alternative to normalizers for the people that actually code plugins. So normalizers, they typically run small tasks, for example, the derivation of the bandgap spectrum that I showed before. But this can like really go, it's like, the NOMAD actions comes from GitHub actions things. And then they allow you to run, for example, these tasks in very specialized hardware. So you have your NOMAD installation running in your machines, and then you can send some tasks to run on a GPU out there. And just naming a few applications of machine learning or AI. So you can use these like to, for example, do data retrieval and natural language processing of papers and creating database from papers where you need to integrate API keys in there. You can use these to run inference from machine learning interatomic potentials and like build databases on the fly from this data. You can use these to generate materials. I think this is a field that is becoming very popular now in material science. So you can, just prompt materials with like inverse design with constraints and then generate structures and then database all of these. And then, of course, you can use this for machine learning assisted characterization, which this lab, for example, needed. And this brings me to the point that now it's not even anymore about fair data. It's fair data, but also fair machine learning models, because we also need to make these models like searchable and actionable. I'll try to bring you an example why we think this is important. So let's say that this lab wants to analyze the X-ray diffraction patterns of all these 11,000 samples. So basically, the way you typically do this, there are different ways, but basically you have like a set of plausible potential structures that these patterns can have, and then you train, you simulate a lot of potential X-ray diffraction patterns of every of these structures, and then you train a model with this. This is typically done in convolutional neural networks. I think this is also done in XPS measurements. But of course, these models are only valid for a given chemical space and so on. So whenever you need to analyze this, you need to search this model for this chemical space and then like trigger this automatically. So basically what we are setting up is that you can also use these search apps to build databases of the models, and you can search them by their chemical space, by the number of simulations per structure that you have done, by the number of epochs that you have run these models, and these kind of things. And then we are like already trying to prototype how this analysis would look. So we ran the first sample the other day, and you go with this map of all these patterns, and then the models start to predict which is the most likely phase that you have in a given point with the confidence interval that you have in there. And then we actually overlay this to the actual image of the sample. We actually said that already in the first try, the models are already detecting pretty well the phase boundaries, and in some cases getting pretty well the phase. So there's a lot of work that we need to do in here to refine this, but it already gives you some hints on how you do this in the platform without code and so on. So this gives me to more updates. So a lot of people have been hearing that we've been trying to develop a new UI, and the reason for that is because we were inheriting this computational platform and so on, and then we needed to adapt it to the experimental world, and then of course there are different design criteria that we have in here, and then we wanted to upgrade this. So I do not have a slide. How am I doing with time? Really bad, no? I should wrap up, huh? Okay, I was going to show something about the new UI, but Ahmed is telling me not to. Can I? Yeah? I can't stop you now. All right, yeah, okay. All right. Yeah, okay, I showed something just very quickly. Yeah? So you have a look on how this looks like. This is going to be tricky to... Can you see this? Yeah, all right. All right, so, okay, this is how the new UI looks like. So for the dark people, you have a dark mode. I prefer actually the light mode. I like it way more. It's very alpha version, so it's not kind of the official release. It's really pre-release. I don't know if Lauri agrees with me telling this. So if you want to learn about this, please talk to Lauri afterwards and from the developer teams. So if you start using it and so on, be aware that there are a lot of features missing, and then you may find a lot of bugs in there. But it gives you already some things of what you can do. So the first thing that you can do is that you can actually go to your profile and edit your institution if you haven't done so. This you couldn't even do in NOMAD before. So you can go to your settings in there. So you can define user groups in there. So if you want to share data with different groups, so you can be the owner of one of these groups and then add and remove people and give rights and so on, so that you can share your uploads. By the way, uploads are not called uploads anymore. Now they are called projects. And there are reasons down the road why we are naming this like this. The apps are very similar. So we have a table in there that will allow you to somehow pin some apps and so on. But if you actually do go to one of them, they actually feel very similar to what they were before. I think there are many things that we still need to improve, and we're working on this. Then it's North, where you can select all your tools that you have in your installation in there. You can pin them and you can run them. It's functionality in here is very similar. And then in here it will come what NOMAD Actions is, which I don't have anything in this installation, but you will see more in the future. And there are many more features coming. So you can, for example, go to one upload, and then all the search apps that you needed to configure before in your plugins, so you can somehow build it almost on the fly in the uploads, so you can search what it is in there and so on. And I don't really want to extend many more, but the whole thing is that we really are working on this very heavily. I think in the next year we will push a lot of new updates into this. We will get also some help from you, but also with some UI and UX expertise to really try to design it to the best of our capabilities. And with this, I will really stop now. And I just want to tell that we have a big ecosystem that is built by a lot of people. There are more than 2,000 merge requests in there. GitLab told me yesterday when I wanted to update these numbers, stop the counts for the commits. So he just kept it, and you know. So this is because this is built by a lot of people that are in this room. So with this, I would like to tell you that this is a great community event. So use it to meet people, to learn about what we're doing here. But like also the other way around, for us, this event is extremely important because it shapes what we will build in the next year. And please don't be shy, talk to people, and we will point you to the right places. And with this, thank you very much.